And we're going to start out by talking about energy. Energy in science is defined as the capacity to do work. So then we have to define work, and in science we define work as the action of a force through a distance. So the illustration here is a guy pushing a box across the floor. If he's just pushing on the box, like I can stand here and I can push on the chalkboard, but it's not moving. I'm not doing any work, right? So it has to be moving. That's just the definition of work. Pedaling your bike across the street, walking down the sidewalk, that's working. I pushed my cup over, that's working. So energy is the capacity to do work, and energy is going to come up in chemistry, so we need to learn a little bit about it. There's two main categories for energy. There's kinetic energy and potential energy. So kinetic energy is associated with the motion of an object. So an object in motion has kinetic energy. Potential energy, there's two kinds that related to position. So here we have a 10 kilogram weight kind of teetering at the top of this building. That's an unstable position. If you give it a little nudge, what's going to happen? It's going to fall off the building. And is it moving right now? Not through space, but when we knock it off, then it starts moving, right? As it gets closer to the Earth, its potential energy decreases, but its kinetic energy increases because it's going faster and faster and faster. Another type of potential energy has to do with the composition of an object, and we'll talk about that on the next slide. So this has potential energy and essentially no kinetic energy. As it falls, it's losing its potential energy, but it's being transformed into kinetic energy. And then it's going to hit the sidewalk, and what happens to all of that energy? It's not obvious. That the energy that it had, the kinetic energy, gets transferred into the sidewalk by making the sidewalk particles vibrate a lot, which you may not be able to detect with your hand or something, but is associated with an increase in temperature. When two things collide vigorously, there's usually heat involved. So the total energy that something has is equal to its kinetic energy plus its potential energy. And the law of conservation of energy tells us that energy is neither created nor destroyed. So we can't lose energy. It's going to be somewhere. It can't just disappear. We also can't create energy out of nothing. Energy can change from one kind to another. It can flow from one object to another, but the total quantity of energy is constant. Things with high potential energy tend to be unstable, like that weight on top of the building. Or, cartoons. They're always hanging pianos out windows. They were actually trying to get the piano into or out of the building, and the door wasn't big enough, so that's why they go through the window. But the rope's always breaking, and it's crashing down on someone down below, right? It's unstable. Another type of potential energy due to composition is chemical potential energy. And this comes from the electrostatic forces that occur between the charged particles that make up matter. So something with high chemical energy might be something like gasoline. So, gasoline burns very easily, right? And is dangerous for that reason. Or something like TNT or dynamite, right? Unstable. You light it and kaboom. Where does all that energy come from? The energy was the chemical energy that was stored in it before the explosion happened. So in physical or chemical changes, energy is always conserved, meaning not created or destroyed. The exception is in a nuclear change. But we're not going to talk about that in Chem 1B. Chem 1A, that's a Chem 1B topic. So systems that have high potential energy are going to tend to change in a way that causes their potential energy to become lower. Like you knock the thing off the top of the roof, and it's going to go down where it's getting lower and lower and lower potential energy. It's not going to go up where it's getting greater potential energy. So in a gasoline-powered car, what's happening is you've got the molecules in the gasoline have a lot of chemical potential energy. In the process of combusting in the engine, those are converted into different sorts of molecules that are released in the exhaust. Those molecules are more stable. They have a lot less chemical potential energy. Where did that energy go? Well, it went into the car. A lot of it is going to be used to move the car forward, but the rest of it will be released as heat. So we're not losing any of the energy in the sense that it's disappearing, but it is lost to usefulness. Any questions about energy?